In 17, this particular problems may seem for some of you elementary, but some of us, don't calculate present value too often in our jobs. But there are very well, many jobs out there that you do this on a routine basis. What I want to do is I want to kind of just talk you through. We have a bond, and we're considering selling it, if you will. It's already issued. It's already out in the market, if you will. And this bond, we need to know how much it's worth. Like, how much is it worth today? So, what they're asking you is what to calculate the market rate. Well, the market rate, is the present value of whatever both the face amount is worth and the amount of interest that you receive from those bonds and what it's worth as well. So you kind of add those together. So I don't want to get ahead of myself here, but you'll notice in the calculation, guys, that they're using 10% stated rate to come up with a face amount of interest every year, which should be 3,000. Okay, but 30,000 times three, times 10%, excuse me, is 3,000. But remember, you have to cut it in half to get the annuity amount, because the annuity amount is what you multiply times a factor in order to get the present value of that interest that you're going to receive every year. And then these bonds, keep in mind, were issued, like, watch carefully these dates and how to count them. But 8 years have gone by and it's only 12 years left. Remember, these bonds, the interest is compounded semi-annually. So that's why we cut the annuity in half here and we double the periods. And then that's why we divide then by 6/12 or 1/2 the annual interest rate, because we need to look up in the tables based on 24 periods and the interest rate for the period. So what you're calculating here is interest rate for 6 months. And that interest rate you would use then when you go to table 6.5, you're going to look for 4%, 24 periods. We're going to pay $1,500. And then this is the factor that you're going to come up with. Now, I encourage you that if you haven't done this already, stop this video now and go ahead and go to the tables and find this 15.2470 factor and understand where it is. Okay. And you're going to be doing this time and time again because you want to repeat this in Connect as well. But we're going to take the annuity and we're going to multiply it times the number of periods. No, the period factors, a factor from the number of periods, right, at 4%. And then we're going to get a number, right? And this is the present value of those payments that are going to be automatically paid based on the state face amount of the bond at a stated rate of 10%. Now notice though that when we go to the tables, we're using the market rate, right? The market interest rate. But when we're calculating the amount of the annuity, we're using the stated rate. So be careful of that. And then we're going to get the present value of the actual 30,000, which is the maturity value of the bonds. And then we're going to take these two numbers and we're going to add them together in order to get the present value, or the market value, if you will, of the bonds. Now, this is a straight up easy problem. I get it. But I will tell you that you want to input this into the computer time and time again, because you're going to see it again. We'll go to 716. And in this particular case, this is not compounded semi-annually. And it's not even compounded quarterly. It's just compounded yearly as an annual interest. So you use the full amount per year of interest, which is 45,000, as the annuity. You see that here, right? And then of course the bonds have a remaining term of 15 years in this case, and the market rate is 12%. Now watch, stated rate to find the annuity, market rate to go to the tables. Using the full 12%, we find this factor and get the present value of all of the annuities. That's the amount of interest paid per year. And then the present value of the maturity of those bonds over 15 years is going to be 82,215 after you go to table 6.4 and get this factor based on 15 periods at 12%. And then you add the two together to get the market rate. So that just gives you a little bit more explanation for those two, which are very similar, just compounded differently. So I wanted you to kind of see that when you did these problems. And you will see this again on the exam, so please be careful here. Now 718 is kind of a recap of 714, but I just want to make sure that we take Adam Endivor Company here issued a $210 million bond, and it said, you know, in the first A, it said how much interest will be paid annually. Well, guys, that's the annuity, okay? So all you're doing is just taking the stated rate and multiplying it times the face of the bond, and you're getting 17,850, right? So what is that? 17,850,000. Okay, and these are issued, we know, at a discount. Why? Because the interest rate, the market rate, is higher. So we know they're issued at a discount. Now, we know that from 714, don't we? Right? And if it had been issued, by the way, if the interest rate had been less than that 8.5%, then it would have been issued at premium. We know that too from our discussion. Well, anyway, the interest expense, then keep in mind, is going to be more than interest that is actually payable, or paid, if you will, on these particular bonds. So it's going to be more, right? Why? Because of that amortization of that discount. So the interest expense is going to be more. Now remember that the interest expense on a bond is both the addition of what you have to pay that is stated on the face of the bond in interest, plus whatever kind of amortization you're doing on your discount on your bond. So you add those together to get your interest expense. Right? And remember too that if it was a premium on a bond, it would be decreasing that interest. It would not interest payable. It would be less. Interest expense would be less than the interest payable. So I hope that doesn't completely confuse you, but we're trying here to kind of explain this generally to you guys, so there's a little bit of an overview while you're going through these calculations.